All right, today we're going over 12.7 normal distribution. So our normal distribution shows data that vary randomly from the mean. So you'll find the mean, you'll find the standard deviation, and you'll look at 3 standard deviations above and below the mean. Okay, the data forms a pattern in the form of a bell-shaped curve called a normal curve, and we're going to go over all of the distributions in a normal curve. Every normal curve has a symmetric bell shape. So if we look at this example here, we're looking at the birth weight of babies. So it says estimate the percent of babies weighing between this range here, 2,500 and 3,999 grams. So if we take a look at that, we want to see, okay, we're looking at the ranges from here all the way up to here. So we're looking at these 3 bars, and then we're going to just simply add them up. So if we estimate and add the percentages, we'll have 23% plus 42% plus 23% is going to give us a total of 88%. Okay, moving on. Here's an example using standard deviation and the mean. So it says for great white sharks, the standard deviation of the jaw width is 2.8 inches. We need to sketch a normal curve showing the jaw widths at 1, 2, and 3 standard deviations from the mean. So we're going to have to do this for above the mean and below the mean. Okay, so it's telling us the mean is 15.7 inches. And the standard deviation is 2.8 inches. So we'll first plot our mean, which is 15.7. Okay, so that's the mean, which we can write it as x bar as the mean. And then we're going to go 2.8 up 3 times and then 2.8 down 3 times. So if we take 15.7 and we add 2.8, we will then be at 18.5. Okay, and this right here is going to be 1 standard deviation above the mean. Okay, so this is a plus 1 standard deviation above the mean. All right, okay, if we keep going here, we're going to add 2.8 again. So we'll add 2.8 again, 2.8. And then we'll be at 21.3. 21.3 because 18.5 plus 2.8 is 21.3. And this right here will be plus 2 standard deviations above the mean. Okay. And another 2.8 above the mean. We'll add 2.8 again. It will be at 24.1. 24.1, and this is going to give us plus 3 standard deviations above the mean. Now we have to go down, so now I'm going to just subtract 2.8. So when I take 15.7 minus 2.8, I'll be at 12.9. This is 12.9, and this is going to be negative 1 standard deviations below the mean, which is going to tell us we have a z-score of negative 1 at the value of 12.9. Okay, we'll keep going here. Subtract another 2.8 minus 2.8 again, and this will be at negative 2 standard deviations away from the mean. Subtracting 2.8, I'll be at 10.1. And last one here, another 2.8 away. This will be at negative 3 standard deviations away from the mean, and will be at 7.3. Okay, so this is showing us the standard deviations away. We need to know that these are z-scores as well, and these are the values at those specific z-scores and so on. Moving on, this is going to be the standard normal curve. So we do need to remember all of these percentages because these are always going to satisfy a standard normal curve. So it's going to be centered on the y-axis. Here's the y-axis. The mean of the standard normal curve is 0. Here's the mean. The normal curve is 0, and the standard deviation is 1. So we're gonna draw this in our bell-shaped curve here. Okay, here's our bell-shaped curve, and then we're gonna look at all of the percentages. So within one standard deviation above the mean, it's 34%. One standard deviation below the mean will be 34%. 1 to 2 standard deviations above the mean will be 13.5. 1 to 2 standard deviations below the mean will also be 13.5%, and 2 to 3 standard deviations above and 2 to 3 standard deviations below will be 2.5. So this will give us a total of 100% of our data lying within three standard deviations above and below the mean. So if we look at this a little bit closer, 68% of our data is going to fall within one standard deviation of the mean. Because if I add these two up, the 34% plus 34%, that will give me a total of 68%. If I continue to add on, then we can see that 95% will fall within 2 standard deviations of the mean. So I'm going to just add plus another 13.5, and our 34s. That's going to give me a total of 95% of the data falling within 2 standard deviations of the mean. So let's take a look at a problem here. It says, in a survey, the responses to the question, how much time do you spend at meals in 1 week, were normally distributed. Okay, the mean was 13 hours. The standard deviation was 3 hours. So we can do a couple of things here, but since we're going to be looking at it being normally distributed, then we can either look at, okay, what values are 1 standard deviation from the mean. We can use this formula here, which would mean the z-score, we would find the value when the z-score is a 1, a positive 1, because that would be 1 standard deviation above the mean, and a z-score of -1, that would be 1 standard deviation below the mean. The other thing that we can do is we can actually draw out our normal curve. So if we draw that out here, we're going to say right in the middle is our mean, and our mean here is 13 hours, and our standard deviation is 3 hours. Okay, so this one here we're looking at is 13 hours. Yay. Okay, 13 hours here, and that's right in the middle. There we go, right in the middle there. Beautiful line. Okay. And then we're going to have 1 standard deviation above, so we're going to be adding 3 hours. So here's 16. Add another 3. 16 plus our 3 is 19. And plus another 3 will be at 22. Okay, and then right here for our next one, we're going to be going down 3 hours, so now we'll be at 10. 13 minus 3 is 10, 7, and 4. Alright, so if we actually go ahead and draw this in, let me just erase this. Okay, so I'm going to go ahead and draw this in now. My normal curve. Beautiful curve here. There we go, something like that. Okay, so now we're going to be looking at it wants to know one standard deviation away. So if we're looking at +1 and -1, then we're going to get a value of 10 and 16. So our values will be 10 hours and 16 hours. And that is giving us one standard deviation above and one standard deviation below. Since it's normally distributed, we know our percentages are 34% here, 13.5 here, 13.5 here as well, and 2.5 here. 2.5 and 2.5. Okay, so the other question that they asked was, what percent of the responses would you expect to find from 10 to 16 hours? Well, if we take a look here, here's 10 to 16 hours. We're just going to add up all of this here, because that will be from 10 to 16 hours. So we take our 34% plus 34%, and we get 68% of our data will fall within 10 to 16 hours. All right, and then finally here, it says in a university lecture class with 174 students, the final exam scores have a mean of 68.5 and a standard deviation of 7.3. The grades on the exam are all whole numbers, and it follows a normal curve. So we have 174 students, the mean 68.5, standard deviation 7.3. We need to find the number of students who receive grades from 1 to 2 standard deviations above the mean. So let's draw this out here. My beautiful normal curve. There we go. That one's not that bad. All right, so here's our mean, X bar. We just said the mean is 68.5. 68.5, right? Yes. Okay, and then we have, we're going up 7.3. So this is going to be +1 standard deviation up. So plus 7.3, 7.3 here. Then we'll be at 75.8. 75.8 plus 2 here, so add another 7.3. We'll be at 83.1, 83.1, and so on. Okay, this will be a -1 standard deviation, so this is 34% of the data, 34% of the data. So now we're doing 68.5 minus 7.3, because the standard deviation is 7.3, we'll be at 61.2, 61.2, and subtract 7.3, again we'll be at 53.9. Okay, so this is 13.5% of the data. This is going to be 2.5% of the data, 13.5, and 2.5. Okay, so we want to find the number of students who receive grades from 1 to 2 standard deviations above the mean. So here's 1 to 2 standard deviations above the mean. That is 13.5% of your data are going to fall within 1 to 2 standard deviations above. So if we have 13.5% of the data, and we knew, we can look back at the problem, it says that 174 students took the test, so we're going to multiply that by 174. So that's going to be 0.135 times 174, and that is going to give us about, let's say, 23.49. So that's about 23.49. We're talking about students here, so it's about 23 or 24 students fell between 1 to 2 standard deviations above the mean. which they got a score of 75.8 to 83.1. Since it's all whole numbers, it said that in the problem that they all received whole numbers as grades. So that means that they really scored between 76 and 83. 23 or 24 students did. Okay, find the number of students who receive grades of 61 or below. Well, here's 61.2. So what that means now is we're going to be using all of these percentages. So we're going to use all of this, 13.5%, and this 2.5%, because this is 61.2, but it has to be a whole number. So that means 61 and below will be 2.5% plus our 13.5%. That's going to be 16% of students scored a 61 or below times our 174 students. So 0.16 times 174 is going to give us about 27.84, which means about 28 students scored 61 or below on the test. And that's going to wrap up 12.7, normal distribution. Thanks for listening. Have a great day.